Good morning. So here's our pre-calculus problem of the day. So we're getting into exponential functions, and this is going to sketch the graph of an exponential function. So an exponential function is exponential because we have the variable in the exponent. It's not a variable with an exponent, so that would be that'd be a polynomial. So exponential means the variable is the exponent, or at least in the exponent. And so in this problem, we want to sketch the graph of this 2 to the x minus 3. Now, I've written out, so it's always important if you're sketching graphs. A lot of times it's important to identify the parent function. So whether you're working with a quadratic or a cubic or a square root function, absolute value function, or an exponential function or logarithm function, which we'll get to, it's important to identify the parent function. And so an exponential function, regardless of what this base is, well, not regardless, but if it's greater than one, so 2 to the x, 3 to the x, 4 to the x, so on, even 3 halves to the x. If it's greater than 1, then it's going to look like this. So we're going to be going up like that. If it's less than 1, if it's between 0 and 1, we only consider positive numbers. If it's between 0 and 1, then it's going to be reflected around the y-axis and going down like that. But this one, the base is greater than 1, so it's going to be an increasing function like this. Then once we graph this, we're going to state the domain range in the asymptote. So it's always important. Well, let's graph this one first, and then we'll talk about those other things. Um, so we did transformations of graphs a few sections ago, I guess. And so if you remember all those rules, the same rules apply. So for instance, you remember things like f of x plus k moves the graph up or down, depending on if k is positive or negative, or f of x minus k, where you put the k inside the input of the function, moves it either left or right. So if k is negative, then it's going to be moving to the right. If it's k is negative, if positive, it'll be moving to the left. So same thing here, or likewise, if you do f of or negative f of x, that flips it upside down. So we can use those same rules here. We have 2 to the x minus 3. So the x minus 3, that's all part of the kind of changing the input. So this is going to be a horizontal move. So we're kind of in this situation here. And since it's subtracting a 3, we're going to be moving to the right, like that. So we have our parent function here. We need to move this 3 units to the right. So 3 units right. And the only real point that, well, I mean, you can plot other points. Obviously, if you plug in uh, 1 for x, you get 2. So the point 1, 2 would be on here. The y-intercept of these, if you plug in 0 for x, you get 2 to the 0. So it doesn't matter what the base is. If this is just a basic exponential function, the y-intercept is always 1. So anything to the 0 power is 1. We could also plug in 2, and then we get that 2 squared would be 4. And so you can get other points. On WebAssign, of course, these are going to be multiple choice. So it's really just a matter of getting the correct shift. Are we shifting left or right, up or down? And that's really going to be it. Um, so we need to move all these 3 points so we know we can move to the right 3 units. So instead of 0, 1, which is on this graph, we're going to move that 3 units to the right. So that'll be at 3, 1. So the x is we're going to add 3 to the x coordinates. So 1, 2, 3. We'll have the y-intercept there, or not the y-intercept, but the y-intercept moves over to there. We know the point 1, 2 is on this graph. So just add 3 to the x coordinates. We get 4, 2. So 4, 2, that would be there. Then 2, 4 is on this graph. So 2, 4, we're going to add 3 to the x again. So that goes to 5, 4. And so 3, 4, that'll be about right there. And so now we can kind of see it's going to look something like this. And so all we've done, we have just moved, we haven't moved it up or down. We have just moved it to the right. So this point moves out here, this point moves out here, and so on. So it's going to look like that. Um, so a couple of things to talk about with the domain and range. So the domain of all these basic exponential functions that we're doing, obviously, if you put weird things in the exponent, like a square root or a fraction, and put an x like 2 to the 1 over x or something like that. This is not true, but as long as you have just a linear function, polynomial, you can do 2 to the x squared minus 4, something like that. The domain will be all real numbers. So anything that we'll see in a pre-calculus class in an exponential function, the domain will be all real numbers. The range, at least when we're talking about the parent function, is going to be from 0 to infinity, not including 0. And so the way you can, I mean, you can just remember that, I guess. But if you have y equals 2 to the x and you want that to be 0, so what value of x to make that equal 0? There is none, because you raise 2 to any exponent, it's going to be some positive number. You cannot get 2 to any number and have it equal 0. So it doesn't work. But any positive number you could get. And you can see this, I mean, from the graph, you can see this is going to go down and approach the x-axis, but it's not going to touch the x-axis. And then we have a horizontal asymptote at y equals 0. So the further we go out in this direction, the smaller the y value is going to get closer and closer to 0, but it's never actually going to touch 0. So for instance, if x is 10 to the negative 20, real small number. 2 to the 10 to the negative 20 is an extremely small, like very small. So we're getting closer to 0. We'll never actually get there though. So the horizontal asymptote is y equals 0. Now with this one, you can really do this. So the same thing we kind of did here. All the points are shifting 3 to the right. So for the domain, if this is a finite domain, you can just take the endpoints and shift them over 3. But since it's all real numbers anyway, the domain is not going to change. Likewise, we haven't moved it up or down, so the range is not going to change. It's still 0 to infinity. And the horizontal asymptote has not changed. If there's no vertical shift, the horizontal asymptote is not going to change either. So if you do a vertical shift, then, so if we did, for instance, f of x equals, let's just say 2 to the x, now minus 3 down here. So the minus 3 is not in the exponent anymore. Then this is a vertical shift down. And so instead of the y-intercept being at 0, 1, we're going to move it down 3, and it'd be at negative 2. And instead of the range being from 0 to infinity, it would be negative 3 to infinity. You'd subtract 3 from the 0. And then the horizontal asymptote would be y equals negative 3. So we got negative 2 is our y-intercept. We have the horizontal asymptote there. And then it's just going to look something like that. And you could figure out what the x-intercept would be. We won't do that here. Domain is still all real numbers. So if you have those, if you remember those rules from when we did the transformations of the other types of functions, the same thing works here. Same thing will work when we do logarithms or any other type of function. So if you take trig, same thing works. So make sure you memorize those. If you have any comments, questions, other problems you want me to do, feel free to leave that for me.